Sometimes you run into situations where you need to do more complex validation than can be expressed in a data annotation or regular expression. Maybe you need to check for the existence of something with the same name in the database, or validate a condition based on the state of another field. The technique I'll show here uses a popular library called Fluent Validation that'll enable you to keep your validation logic isolated from the rest of the code. This has many benefits, not the least of which is being able to more easily see what makes an object valid. We're looking at the README preview again, and I've got a little block here for Fluent Validation. Here are the docs, and if you look at the little sample code here, you create a validator class that inherits from the generic abstract validator class of the type you want to validate. And then the constructor contains a list of your validation rules, which can include simple rules like the ones we set up with data annotations, but can also include custom methods for more interesting validation. And when using this via dependency injection, which we'll be doing, we can use the automatic registration technique to make sure that any classes that inherit from abstract validator in the assembly with the validator we reference will be made available to us. Let's get this NuGet package added and create a validator. I'll open the terminal view and change into the directory where the CSproj file is. Then it's just .NET add package fluent validation.ASP.NET Core. That'll add the NuGet package, and we should be ready to go. I'll add a file to the logic folder called productvalidator.cs. If you wanted to create a separate folder for validators, or put this with the models or objects you're validating, that works too. But to me, this feels more like business logic, and that's why I put it here. I'll paste in the code for this validator, and now let's run through it. This class inherits from abstract validator of type product model, which is what we'll be validating. The rule I've created is a little contrived, but what it's doing is some conditional logic based on the category. If the category ID isn't 0, it retrieves the full definition of the category from the database via the repository that we're injecting from the DI container. If the category name isn't footwear, we just return true, indicating that the validation passed. But if the category is footwear, then we make sure the price is less than or equal to 200. If it's more than that, the validation will fail with the message in the with_message extension method. The repo method we're invoking here doesn't exist yet, so let's add that. It's just a getById method on the category ID. Here's the repository interface definition, and I'll paste the new method signature here at the bottom. Then here's the repository class itself, and I'll paste in the new method body, which simply uses the first or default method on the categories DB set of the EF context. That makes the validation method happy, but now we need to consider how this validation method will get invoked. First off, let's make the validator available in the DI container. So we go back to program.cs and can use that add validators from assembly containing method we saw in the Fluent Validation docs. If our validation method wasn't async, we could have auto-injected this into the pipeline by just adding Fluent Validation to the services here in program.cs. But our validation is async since it's hitting the database, so we need to invoke the validation manually. So let's go over to our product logic class and add it there. I'll add a parameter for iValidator of type product model to the constructor of product logic here, which should pull in our validator from DI. Then I'll set a private field for the validator and update it to have an underscore prefix. I don't want to change what we're returning from the addNewProduct method, but I do want to invoke the validation here. We can use the validate and throw async method on our product model, which will throw a validation exception with the errors property of the exception containing the validation errors. Once again, there are other approaches you can take here, and yours will be up to you. But now let's pop back to the controller code where this addNewProduct method is called. Here's that method, and there's an if block regarding model state that gets checked first. Since we still have some validation that uses data annotations, we should leave that in place. But the addNewProduct call may throw a validation exception, so let's update this code to catch that, add the errors to the model state, and return the view with the errors. I'll invert the model state conditional first, and then add the try keyword to enable us to catch a validation exception. Then I'll add the catch block for that exception type. The validation type will require a using statement for Fluent Validation, then we'll get a block for the catch, and create a results variable from the validation exception. Actually, the results get created from the errors property of a validation exception. The results object has an extension method called addToModelState, which will add any errors to the ModelState object, which is part of the base controller class and what's used within views to show errors. There's a second property for a prefix on the errors that we don't need to use here, so null is the second parameter. Then we just return a view with the product model object that was passed to the method, which is what had the validation error. Let's run this and try it out. We should trigger the error if we create a new product in the footwear category and give it a price of more than $200. Here's the app. I'll go to the listing page and create a new product. Provide a name, choose footwear, add a description, and make the price $300. When I click Create, we see a validation error with the error we expected. Nice! This error is in a bulleted list at the top of the form since we didn't directly associate it with the price property. Feel free to explore how to do that on your own if you want. But there's a problem here. Our category selection of footwear is gone, and what's worse, we have no options in the dropdown. This is because the available categories property value wasn't submitted as part of the form, and we need to get those values on the model before we return the view in a validation error. Let's fix it real quick. Back in the controller code, we can put that new method we created to get the available categories with a product model to use. By adding this call, we'll have those values set. I'll rerun the app now and try the same thing again. Provide similar values for creating a new product that'll trigger the validation error. It does trigger the error, but this time the category value is saved, and the select list is there too. So now you've seen a technique that lets you do more complex validation, even involving selecting from a database, and keep that logic nicely isolated. Let's wrap things up here and see where we're headed next. This module has solidified many things that we've been discussing throughout the course. We've changed the schema in the database, modified the app to accommodate the changes, and added some more complex validation. If you're the type of person that likes to reinforce what they've been seeing by trying some things out on your own, you're in luck, because there are some great opportunities here with things I've left undone or incomplete in this module. We only applied our new Fluent validation logic on the create method. You could use what we've already done and apply it to the edit method and make sure it works. We also scaffolded out a categories controller, and earlier in the course we pointed out the shortcomings of the scaffolded code. What's in place does work, but you could update the new controller to not use the DB context directly. Either use the repository or a logic type class that in turn uses the repository. You could also update the category object and table in the database to have a max price property that would drive the validation rule a little bit more dynamically. All of this is optional, but would provide great opportunities for practice and leveraging the things that we've already gone over. We've pretty much rounded out the application itself now, but there's one more topic that comes up in almost every app: authentication and authorization. Let's have a look at that next. We've built some nice functionality into our application so far, but it's missing a couple of key features: the ability to log in, and for our app to require authenticated users. Authentication refers to the ability to verify the identity of a user, and this often happens with passwords and sometimes with multi-factor authentication. Authorization, on the other hand, refers to the permissions that users have to perform tasks. They're definitely related, but also not the same. This module will only scratch the surface of this important topic. To be sure, that's been true for most of the course, but it's even more so here. I'll make sure to point out more resources for you to dig deeper on this and other topics later and in the next module. Before we go any further though, I want to make a point as clear as I can. Please don't roll your own authentication framework. Security nowadays is super important, and it's way too easy to get this wrong if you go down the path yourself. Take advantage of the good work that others have done and then make the customizations to meet your own requirements. To that end, when we first created our project, we ignored the authentication options available when creating it. Let's circle back on this topic and see what those options were. Here's Rider again, and you can see the same options from both Visual Studio and from the command line. It's way easier to see and explain in Ride or in Visual Studio than it is from the command line, and that's why we're here. I'll go to create a new project, and I've got the ASP.NET Core web app and the MVC flavor of it, which is what we used. There's a drop-down for auth that has the choices we can consider here. I'll go through the choices in a sec, and please understand that these are all things that you can retrofit later for sure. We'll be doing that in our own app in a sec, actually. I'll create a new project real quick with the individual auth and Azure AD B2C option. That creates and opens the project, and if we have a quick look at program.cs, we can see the operative code. There's a couple of lines to add authentication, and a Microsoft Identity web app that reads some configuration from an Azure AD B2C section. Then there's a couple of lines that add Razor pages and Microsoft Identity UI for the auth-related pages. The configuration is in App Settings, and there's a section for Azure AD B2C just like you'd expect. You would update these settings with your own values from the Azure AD B2C provider that you've got set up, and then you should be off to the races. As a final aside here, there were also a couple of NuGet packages added when we chose this auth method, and you can see them in the csproj file or in this list of package dependencies for the project. Let's circle back now and cover the auth options briefly. Here's an overview of the authentication options available to you when setting up ASP.NET Core web projects. And it bears repeating that any choice you make when setting up a project is not irreversible. Any of these choices just adjust the code and dependencies of the project that gets created, and you can always go back later and make similar adjustments yourself. The first auth option is individual accounts, and this is the simplest one conceptually. It means you'll be storing usernames and passwords within the context of the web application, often within the same database that the web app uses. Keep in mind that if you choose this option, it definitely means one more password for your users to keep track of. The rest of the options here are going to imply some kind of single sign-on, where this app no longer needs to keep track of the password or perform authentication for the user, but rather send it somewhere else that'll do it. Individual accounts with Azure AD B2C is what we just saw, and it means you're using the Azure AD B2C service and will provide the configuration to wire that up. Organizational, single tenant, means you're creating an app for a single company that uses Azure AD, and you'll hook into that for auth. Organizational multi-tenant means almost the same thing, but you're creating the app for more than one company that will be using Azure AD for auth. Windows is still available as an auth method, but this actually means that you're tightly connected to running in a Windows environment and with Windows domain accounts. Unless you very clearly need exactly that, the single-tenant Azure AD choice might be a better option. Finally, you can also choose no auth, and that doesn't mean you don't want auth in your app, but rather that you'll add whatever code is needed yourself. A really common option here is to use the OpenID Connect authentication package and hook into any standard OpenID Connect server you choose, which might be a Duende Identity Server instance which you've set up yourself, or Google Accounts, or Auth0 or Okta. Hopefully there's an option in here that sounds like a good starting point. Definitely choose one of these rather than writing your own if you can help it. We're going to add the individual accounts, meaning local usernames and passwords, to our app now so you can get a little look at how ASP.NET Identity can support you if that's what you need.